Hi everybody. Today I am going to discuss about the topic Mannich reaction, which is an important addition reaction. The reaction involves an analyzable aldehyde or a ketone, a secondary amine, a formaldehyde in the presence of HCl to give a product beta amino carbonyl compound. Here, an analyzable aldehyde or a ketone means an aldehyde or a ketone with alpha hydrogen. So, if you use an analyzable aldehyde, we get a product beta aminoaldehyde from the addition of one molecule of formaldehyde and amine to the aldehyde. If we use an analyzable ketone, we get a product beta aminoketone from the addition of the formaldehyde and amine to the ketone. Let's see an example here. An acetone, formaldehyde and a secondary amine is reacted to give a beta amino ketone. Here you can see the H from acetone and an O from formaldehyde and the H from a secondary amine is removed, and these three compounds are linked to give the product. Let's see another example, a reaction of acetophenone with diethylamine and formaldehyde. Here, as you can see in the reaction, amine and formaldehyde are linked together to give an addition product which react with the acetophenone to give the final product. Here, the Mannich reaction product or the product of Mannich reaction is known as the Mannich base. So, through Mannich reaction, we can get the product Mannich base. Let's look at the mechanism of Mannich reaction. The mechanism involves the preliminary formation of imine salt from the amine and formaldehyde. So, amine is a nucleophilic and it attacks a more electrophilic carbonyl compound. In here, it is the formaldehyde. So, they two react to get an imine salt in the presence of HCl. So, the imine salt produced here is R2 N plus double bond CH2 Cl minus. No acid is needed for this addition step, but acid catalyzed dehydration of the addition product gives the imine salt. So, an acid is not necessary for this addition reaction, but an acid catalyzed dehydration of this addition step gives the product imine salt. In normal Mannich reaction, this is just an intermediate, but it is quite stable, and the corresponding iodide is sold as Eschenmoser's salt for use in Mannich reactions. Let us look at the second step. Electrophilic salt can now add to the enol of the ketone to give the product of the reaction a Mannich base. So, the electrophilic salt, which is the imine salt, is added to the enol of the ketone to give the Mannich base. Let us look at the applications of Mannich reactions. A. Mannich bases as intermediates in synthesis, for example, formation of alpha-beta unsaturated carbonyl compound. The Mannich reaction normally gives the hydrochloride of the Mannich base. These salts are usually stable at room temperature, but those derived from aliphatic compounds undergo elimination on being heated. So, the hydrochloride of Mannich base are the normal products of Mannich reactions, which is stable at room temperature, but that derived from aliphatic compounds undergo elimination on being heated. This is Mannich base hydrochloride. This undergoes elimination and the N plus HCH3 twice Cl minus group is removed and a double bond is formed. This reaction is similar to Hofmann elimination of quaternary ammonium salt, but that reaction, the Hofmann elimination of the quaternary ammonium salt, requires a strong base hydroxide ion. But in the case of Mannich base hydrochlorides, this elimination is readily because the double bond that generated is conjugated with a second unsaturated group in the compound. The second application is that the Mannich reaction is an important synthetic pathway in the biosynthesis of alkaloids, and many such reactions have been duplicated under the laboratory conditions. Thus, tropinone can be synthesized from succinaldehyde, methylamine and acetone. So, tropinone is synthesized by a Mannich reaction between succinaldehyde, methylamine and acetone. It is also used in the biosynthesis of alkaloids. Let us look at the structural requisites in the reactions. The amine may be primary or secondary. In the former case, the product, a secondary amine, usually react further. So, the usually used amine is secondary amine. Let us look when a primary amine is used in the Mannich reaction, it gives another secondary amine which further reacts with an ketone and an aldehyde to give another product that is given in this reaction which has two carbonyl groups linked to a nitrogen. When ammonia is used, usually it results in three successive reactions to give the desired product. Aldehyde is commonly formaldehyde, but higher aldehydes have been used successfully. So, in Mannich reaction, we commonly use formaldehyde, but higher aldehydes also react with the amine to give the imine salt. The third reactant may be an anode, a related compound, or any compound capable of undergoing analyzation in the presence of acid. As I said in the definition of Mannich reactions, the third reactant is an analyzable aldehyde or a ketone. But we can use any other compound which is capable of undergoing analyzation in the presence of acid. So, we are using more important classes of compounds as the third reactant with formaldehyde and dimethylamine and is undergoing Mannich reactions. First one is aldehyde. As you can see, the reaction is given below. And the second one is ketone. And in the third case, we are using beta dibasic acids, beta cyanoacids, beta keto acids as the third reactant, and we get this result. In the fourth case, 2-methylpyridine and related compounds are used as third reactant. In the fourth case, furan, pyrrole, indole and its derivatives is used. In the fifth case, phenol is used as a third reactant. In the case of furan, pyrrole, indole and its derivatives, they are so sensitive to acids and the Mannich reaction must be carried out in a weak acid like acetic acid at a low temperature. Okay, by this I am concluding my seminar. Hope you all understood. Thank you.